very much. Thank you for the introduction, and great to be here at GOTO in Amsterdam. Being Dutch, it's quite nice to be at the GOTO conference in my own country instead of in other countries. Great to give you a little more insight around smart contracts, because where blockchain in itself is quite hyped and sometimes poorly understood, smart contracts, and also due to the name, is quite hyped also in sectors outside the IT world and even worse understood. So it's quite nice to give you a better understanding of what smart contracts are, how do they work, which blockchains can handle smart contracts, and also some pointers to building robust smart contracts in the end, because a lot of stuff that go wrong within blockchains at the moment have to do with poorly coded smart contracts, etc. And also I'll point out some effects on the various value models that we have in the world, where smart contracts really can make some changes. But let me briefly introduce myself. Can I have my slides up, please? Thank you. So this was my first slide. Now you've seen it. Very good. Let's continue to the second one. My name is Olivier Rikken. I'm an engineer by background, but that wouldn't surprise you. I once graduated on system engineering on the Technical University of Delft here, building simulation models for a few years, and then ended up on the business side also by doing an MBA and understanding the rest of the business a bit better. And approximately four and a half years ago now, I came into contact with basically the phenomenon of blockchain. And this hit me so hard in such a good way that I decided that almost 3 years ago it would become my full-time job. And it's been my full-time job for almost 3 years, and the people who were in the presentation just prior to this had a presentation about how long does Ethereum exist. Well, the first really workable version, Homestead, was released in March 2016, and I've been working with Ethereum with smart contracts since April 2016. So quite from the beginning. And well, I've got multiple roles in the blockchain world. First of all, Director of Blockchain and Smart Contracts at Axveco, just a consultancy firm. But furthermore, I was involved in the founding of the predecessor of the Dutch Blockchain Coalition. And also I'm the spokesperson for the Netherlands in the ISO World Standardization Group around smart contracts. So smart contracts is basically my life, which is quite sad, to be quite honest. But let's not go there. But one of the most important things that I did in the past 2 years, I would say, is a part of the work I did for the Dutch Blockchain Coalition, because 2 years ago I presented an idea for a startup. I've been working on Assurance, a peer-to-peer insurance company on the Ethereum blockchain, and I presented this idea to the Dutch regulators, being the Dutch National Bank and the Authority for Financial Markets. And I said, well, due to the setup of smart contracts, etc., we can basically forget all the regulation, because we can build an insurance company that doesn't have to adhere to Solvency II, because there's no risk. And I was making my presentation, and the people in the room over there were lazily staring at me for like half an hour, and it was me against 6 people on the other side of the room. It was kind of a Spanish Inquisition. And at the end of the presentation, they were like, all right, it's really nice, but we don't understand blockchains. Are smart contracts legally binding, yes or no, etc. And at that point I decided, okay, there's so little knowledge around this word smart contracts and so many misconceptions around smart contracts. Let's start a work group. So I've been running around through the Netherlands and finally got 4 partners from big law firms, a couple of ministries, and a lot of techies into one room. So in total 20 parties, sitting down together for almost a year, figuring out what are smart contracts. Are they legally binding? Is it just code? What is it in the end? And what are the future knowledge needs if we want to deal with them? And part of those results will be presented here today as well. And I can tell you it was quite interesting to have professors and partners of law in the room on one hand, and just IT guys like me on the other hand, both using the word contract and having a completely different view of what we were talking about. So that was quite interesting process that we went through. But enough about me, let's talk about smart contracts. And before I go there, I briefly want to touch upon what can we use blockchain for again. Jana already mentioned in the presentation prior to it, but basically we can use blockchain for 3 things. One, obviously, is the transfer of value. The transfer of value through cryptocurrencies to tokens to whatever. Cryptocurrencies have a value of their own, tokens have a value that we attach to it basically because of an agreement that we make or a promise that we make. But this is basically what blockchain was invented for. The transfer of value without the need of a trusted third party in order to make sure that this transfer was allowed to be go from A to B. But the second thing we use blockchain for nowadays, and that was actually not what blockchain was invented for, but was just one of the characteristics, is that we use it more and more for the secure storage of data due to the immutability characteristics of blockchain in itself. Once it's on a blockchain, you can't change it anymore. It will be there forever, which can be a challenge if you want to invoke your right to be forgotten under GDPR, but let's not go into that one today. And finally, as of a few years ago, we are able to store logic on blockchains. Basically, if-then-else statements that can either result in the transfer of value or an update of a data point. And it is this logic that we call smart contracts. So basically, if we take it down to the simplest form, smart contracts are pieces of logic that we store on a blockchain. And these pieces of logic can be the condition for a transfer of value or for the update of a storage. That's it. Plain and simple. No more, no less. But is it just code then? Well, let me start with a few misconceptions around smart contracts. And the three main misconceptions around smart contracts are this. First of all, when I talk about smart contracts, I refer to blockchain smart contracts. But first of all, it always was said that it's just code. It's not a contract. It's a piece of code that we deploy in a contract that's, on a blockchain, and that's it. But if you look at what it can do, it can entail the rules for conditional transfer of value, and it can hold the value in itself as well. And this all without a trusted third party in between. So maybe this code is a bit more than just code, because it holds value and it can transfer value if the right conditions are met. And this is what got me triggered, maybe we have to involve the legal guys. And at that point in time, I got the legal guys involved, and they were all hyped and nervous because of the word contract. Because they thought, hey, it's going to be the future of everything we do at the moment. And I actually read a few papers from really professors in law. They were talking about smart contracts, and I knew one thing for sure by reading their article: they never had seen a smart contract in their life. That was for sure. They just heard the word for it. So is it just code, or is it a contract? It's somewhere in between, and I'll come down to that later on. And by the way, why do we start it out with it's just code and not a contract? It's due to the fact that the whole term wasn't even invented by the legal world. It was invented by a software engineer, mainly Nick Szabo, in 1994. So even way before blockchain even existed. Only the power of smart contracts is completely fully unleashed due to the fact that we have blockchain as well. Well, so this is one of the main misconceptions. It's more than just code. The second one is, how smart are they? It says smart contract, but that's just a name for it. Well, and if we go back to what a smart contract is, it's a piece of code that's being deployed on a blockchain. And as it is on a blockchain, that means that per definition, it is reactive. Because a blockchain is not going to do anything unless it gets a transaction in. And this goes for a smart contract as well. A smart contract is a piece of code that sits on a blockchain and waits there until a transaction comes in. That means it can't automatically scan the environment, and basically all smart contracts in the world cannot look outside their blockchain. They're deaf, they're blind, they're just reactive, waiting there for something to happen. So a message comes in, and then it starts reading its code, and it can do something according to what has been coded. It isn't self-learning, it's completely deterministic. So we had one misconception: it's not a contract. The second one, it's not really smart. So yes, it's not the best chosen name ever. We do have to admit that one. And thirdly, as we can't speak about the blockchain, we can't speak about the smart contract as well. Because the characteristics of a smart contract depend on the blockchain they live on. And we have different kind of blockchains. We have tokenized blockchains, non-tokenized blockchains, permissionless. We have all different kind of characteristics that adhere to a certain blockchain and thus adhere to certain smart contracts as well. So a smart contract on Hyperledger looks different than a smart contract on Ethereum due to the simple fact that Hyperledger doesn't have a cryptocurrency. Period. So what is a smart contract then in itself? And what does it look like? And the best example that I can give you right now, what are the elements of a smart contract on the Ethereum network? And why on the Ethereum network? It's the most used smart contract network that we have at the moment, or the biggest smart contract blockchain that we have. And if we look at a smart contract on Ethereum, it actually consists of 4 elements. And the first one is a nonce. You can forget it right now. If you were in my workshop last Monday, you would now understand why it's so important. But the second thing is, it's an account. Like Jana said already, it's an account, and thus it can hold a balance. So a smart contract can hold a balance, and in this case, a balance of Ether. So it can hold value, because you can interchange your Ether for dollars if you want to. So it can also transfer value. And how does it transfer value? Due to its code. And its code are its functions. And that's the rules that you basically code into that smart contract. So that's the second important element for now, forgetting the nonce, obviously. But so the contract account's code is the second part of a smart contract. And thirdly, it has its own storage, meaning we can store variables in a smart contract. Thus, we can say, we can make a smart contract saying, if this shipment comes in, or if the status of the shipment is in harbor, then I'm going to pay out. And this status in harbor can be one of the variables that you make yourself. And this smart contract in itself is an account, and this account lives on the blockchain on a certain address. And due to the transparency of blockchain, and it's in this case Ethereum, everybody who wants to can see the code of this smart contract themselves. And also all the variables if you want to and if you're a bit handy. And also the prior states of the variable, etc. But every time we call a smart contract, so we send a message to a smart contract, it either results in an update of the state, and we mean that we update the variable, so something in storage, or it will send out ethers, or it can receive ethers, or whatever. So it can do anything arbitrary how you made it yourself. And now, to trigger some interaction from your side, there is one line bold and italic. The contract account's code. It's obviously there for a reason, so I'm asking you now, why is it in bold and italic? Any ideas? Jana, you're not allowed? Shout, come on. Yeah?
That's the difference between smart contract accounts that has that and an external account that doesn't.
Very good. Not the one I was pointing on actually, but very good. So it was said here, that's the difference between an externally owned account and a smart contract account. Yeah. So the account will only do something according to its code within a smart contract. Now the most important reason that I put this one in bold and italic is due to the fact that everything that is immutable on a blockchain for a smart contract, it is that its code is immutable. So once you deploy your code on a blockchain, you can't alter your code anymore. You can update a variable, you can send ether to a smart contract, and the smart contract can send ether out, so the balance can go up and down, the variables or the storage can be updated to a new value, and see it as a new value is put on top of it, because you can always see the previous values, because we can't delete that. But the code in itself can't be altered anymore. So an amendment to a smart contract, adding extra functionality, is not possible. You can kill a smart contract and then deploy a whole new one with the added rules and functions in it. That's possible. But adding a single function in it, that's really, really hard. And I do have some pointers right at the end of the presentation how we could deal with this and how we can still have a bit of flexibility in smart contracts, because once they're out there, you want to have some flexibility in it. Because if everything is hard-coded and fixed, then the number of use cases will go down drastically. So you want to build some flexibility in there. So is this clear so far? Yeah? How many of you have ever seen a smart contract? Well, that's a good score, but normally it's like 1 or 2 people. But this is actually what a smart contract looks like. It's just a bunch of lines of code. So we have here right here, this is the contract, these are all the variables, so this is basically the storage that we put down, and here are some functions. And you can call on those functions individually if you want to. But here, you see that it's just code, and for a developer we can read this code and that's okay. But what has this to do with a legal contract in the end? Because this is still code, and if I show this to my mother, she wouldn't understand it, so we will have a hard time of making it legally binding, yes or no. By the way, this code is then deployed on a blockchain, it lives on a certain address, and if you click on that address, you can see everything around that smart contract. Being, you can look at the code if you want to, you can see all the incoming transactions ever to that smart contract. The internal transaction means the outgoing transactions as a result of an incoming transaction. All these kind of actions, that's this complete history of what happened to this smart contract is what you still can see in a blockchain. But if I want to interact with this, and again, I did try to show this to my mother, and she really didn't understand it, well, she's never going to work with it. So if we want to interact with it, we always have to make a front end. And that can be a very simple website like this. I'm quite handy in Solidity, that's the language you see over here. I'm quite basic at CSS, as you can see over here, but that doesn't matter, it works. And this is how people will understand it, because they can read what the code on the background will do. And bear that one in mind, because that's going to be extremely important for it to be legally binding in the end. Yeah? All right, so what are these smart contracts then towards the legal contracts? Do all the lawyers in this world and the notaries in the world have to be very, very scared due to the fact that their world is going to change completely, or is it just code in the end? Well, if we go back to the bare basics of smart contracts in themselves, like I said, blockchain smart contracts are nothing more than pieces of deterministic code that we deploy on a blockchain, period. And we had, with the smart contract work group, with the research that we did, we looked at the 7 most applicable kind of legal agreements that we have in the Netherlands. We looked at it under Dutch law. And actually we saw that a lot of the traditional legal agreements are not suitable for translation into code. Why that is, I'll come back to that in the next slide as well. So, yes, most of the smart contracts are not legally binding, and most of the legally binding agreements are not suitable for translation into code. But there is a very interesting overlap. There is an overlap where the code in itself can have the legal meaning, and thus can be the legally binding contract as well. But if you want to do that, we recommend only to do that for the execution only. And why that is, I'll show you that in the next slide. But it is very interesting, because now, literally, code can almost be law. So we can code smart contracts that in themselves can be the legally binding agreement, which is kind of cool, because then we can make the contracts ourselves and we don't need lawyers anymore. That would be quite nice, save us a lot of money, at least, that's for sure. You need programmers instead, and a special breed of programmers, and I'll come back to that in one of the last slides. But, all right, so why is it? Why do we recommend that if you want to make a legally binding smart contract, only to do so for the execution of it? That has to do with the setup of traditional contracts. Because if we look at traditional contracts, they exist of 2 parts. The so-called operational semantics, then if this happens, then I'm going to pay out. For example, if you did your work correctly, your boss is going to pay out your salary at the end of the month. These are simple if-then-else statements. And every contract basically has them. If this happens, then I'm going to pay out. Or if that happens, then you're going to pay me, or whatever. These are all the basic contracts. And this is what we call the operational semantics. But if we look at traditional contracts, they do have a lot of other text in it. Because if you would take out the rules of a contract, you probably could bring back every contract to 1 A4. And if you don't, I don't know how many of you have looked at an average contract, especially under English or American law, then it's like 70 pages. That's the part you have to scroll down to online and then hit OK. So, and that is what we call the so-called denotational semantics. So it's the surroundings of a contract. And an example is, this contract is under Dutch law. And if we are in a dispute, we go to the court in Amsterdam. And it has to adhere to the general terms and conditions that nobody has ever read, etc. So these are all pieces of information that are part of a traditional contract as well. And it's easy to guess which part is the easy translatable part to a smart contract. What is the part that we can easily translate into if and else statements? It's the operational semantics. So if you want to make a smart contract part of a legally binding agreement, then you can easily translate this operational semantics into code and thus have the execution of the contract being done immediately. But if you want to have the whole part legally binding, you have to do a little bit more. And that is a bit trickier, because then it comes down to a few important legal pointers if you want to make the whole code legally binding. And this first part is that everybody who works with the smart contract has to fully understand what the smart contract does. So if we set up a smart contract between two Solidity programmers, then it's no problem, because they can both read the code and understand what's happening. But again, if I would set up a smart contract between myself and my mother, I would have to have a translation in Dutch, normal, plain language, saying what the code is going to be done. And it sounds trivial, but it's quite interesting to see what's happening then, because literally speaking, the rules and execution of the rules and the signing of the rules only happen in the digital environment. So in this case, we make a smart contract with functions in it, etc., and we send a transaction to it, which is the signing. So technically speaking, all the rules, etc., including the signing, is done on the smart contract. But we need to have an extract, and it can be on a website, it can be a PDF, we don't sign anything, etc. But if we don't have that extract explaining what the code is going to do, then the smart contract in itself is not legally binding. But if we do have this simple extract, and it can be something like, if we both voted yes, then I'm going to pay out, something like that, then in itself it is legally binding. So the code can be the legally binding part. So that also means that judges, etc., will need to have to learn code, but more importantly, they will must be able to make a translation from code into formal language and back. And this is where there will be a challenge in the future. So the second thing, if you want to make it a smart contract, a completely legally binding agreement, are things like how do we deal with dispute resolution? The fact that we make a contract in code doesn't mean we can't have a dispute in the real world. You can deliver, you can't deliver. So you always have to think about it. And a perfectly valid answer is that if we have a dispute, we still go to the court in Amsterdam. It is a valid answer. The only thing is maybe the execution of the contract already triggered, so maybe the payment went through already, yes or no. But that's just something else. Yes?
You like some interaction, right?
Yeah, absolutely.
So has it already happened? Is there a jurisdiction on
Well, that's quite interesting. Jurisdiction in itself is quite a tricky thing within the blockchain world. And I can give you a real-life example of that one. I've been involved in Swarm City, one of the oldest startups on the Ethereum network. And in the beginning, we were just this corporation, and we came together on GitHub, and that was it. And we lived all around the world, literally. So what happened there is that at one point, we had to do business with the normal world, and we created some funding through an ICO, and we had our funds on a smart contract on the Ethereum network. And at the point that we wanted to do business with the real world, buy a laptop, etc., these companies asked us for a VAT number, which we obviously couldn't give because we were just a corporation on GitHub, and that was it. There was no legal formal structure. So the guy leading the pack, in the end, he founded a GmbH in Switzerland under the great name Old School. Otherwise, we couldn't do business in the old school world. And actually, at that point, the tax authorities in Zug woke up. And this was before all the ICOs and everybody in Zug knew about what was happening. And they asked us a question. They said, well, it's nice that you have Old School and that you have funding, but where is this funding stored? Which bank account? And we're like, oh, it's not on a bank account, it's on a smart contract, on the Ethereum network, etc. Okay, that's cool. So where is this Ethereum network? Well, that's the cool thing about blockchain. This Ethereum network is in all the nodes in the world, so about 20,000 nodes worldwide. And then they said, well, okay, we kind of get around the idea of blockchain and the nodes, but can you at least tell me where the original of the smart contract is? And then we had to say again, well, the original is on all the 20,000 nodes in the world, so you tell us under which jurisdiction our money is stored. This was kind of a different discussion, a difficult discussion that we had for a long time. And then we hired a way too expensive law firm to find it out for us. And they said, well, you can store this at a certain island, or register it at a certain island, just the same as seafaring ships can be registered in Switzerland. And I always wonder, how the hell do these ships come from Switzerland to the sea? But that's just me. But we were able to register it on a small island in the Pacific, which is obviously for tax reasons, and it's perfectly legal. The funny thing is, this island doesn't have a server park, so technically we can't store it on that island. But that's so it's a nightmare jurisdiction and blockchain. We just don't know how to deal with it. So if you want to deal with it, you have to make some reference in the smart contract itself, saying this smart contract is under this and this law. Because from the physics, where we normally could derive from under which jurisdiction it would be, it's much harder to do than in the past. That's basically what it comes down to. A long answer to a short question. Yeah? All right. So let me continue. The terms of automated execution. As it is public, as it is open, everybody can see the functions. So everybody, in theory, can call the functions as well, even if they're not allowed to. So governance around it is quite important. Who's allowed to call a certain function, yes or no? And finally, we have to make a distinction between, is a smart contract deployed on a permissionless or a permissioned blockchain? And even the law in some states in America make this distinction. Because a smart contract on a permissionless blockchain or a public blockchain like Ethereum is really immutable in this case, because then we have to change, put in a whole hard fork in in the whole network. But in a permission blockchain, you don't know how many miners are there, how many full nodes are there. So updating the software there and altering stuff is in theory much easier. So you see that some states in America say, well, under permissionless blockchains, we do agree to the fact that the immutability is complete, because it's so hard to get more than 50% of the network doing this update, and in a permissioned that's easier. But that goes a bit too far now. So with regards to smart, so these terms for automatic execution are very important. So the best thing to deal with this is actually controlling where does the message come from, and you have to agree to that up front. So with that regard, what we use a lot in this case are oracles, saying if the information is in a certain oracle is updated, we agree to the fact that this information is true. But it's basically, in the end, an agreement between the parties in a smart contract. And the example that I give over here is KNMI, that's the Dutch Weather Institute. If the Dutch Weather Institute states it was a storm, then we're not going to have a discussion if there was a storm, yes or no. No, then it can execute. But remember, a smart contract is reactive. So in this case, your website or the KNMI database needs to send a message to the smart contract stating that there was a storm, and then it can start doing something. So my smart contract can't look into the KNMI database to see if there was a storm. It is quite important in how you design your processes. Furthermore, obviously IoT is a very, very nice one in order to trigger smart contracts. We are already experimenting, for example, with sensoring in Windows that can censor if the window is broken. And this then in itself sends a message to a smart contract, which can represent my insurance policy and thus automatically can pay out if this window in particular was insured for breakage, including breakage of my own fault. So then you have the strange situation that as soon as your son shoots his soccer ball through the window, you will see an update of your balance on your wallet and see that your window is broken due to an updated balance on your wallet. So, but that's something different there. But also don't rule out the human factor there, because a lot of people think we're gonna do it all automatically right now. But an oracle, in a lot of cases, people think about databases that we trust, but it can also still be a function that we trust, especially if we have a dispute in a contract. For example, we do contract payout by voting. You send me some goods, and we both vote on the fact if the goods were sent, yes or no. And if we both vote like this or like this, the funds are going to go this way or that way. But if we vote like this, then the smart contract can trigger a message to a third party, say, hey, please look into it. Where do the funds have to go? So don't rule out the human factor yet. because there are a lot of cases that we can still use that human factor there. But you can, at an early stage, at least flag the dispute. So not that it will be there for like ever, but immediately when there's a dispute, you can flag it. Yeah?
Yeah, you triggered a lot of questions. So
that's good.
you created the term oracle, so then
yeah.
That's an identity. So how do you prove your identity?
Well, identity is a valid point, and one of the 3 pillars that we work on with the Dutch Blockchain Coalition is to create trustworthy digital identities that you can always identify yourself being you at that point. At this point in time, in a blockchain, your identity is your account number. So you have to prove somewhere that you are connected to this account number, and that account number is unique. See it as a Swiss bank account number. So you can open it anonymously, but that represents you, and if you have identified you behind it, then this number. Yeah. Yeah, absolutely. So, and finally, with regards to the 3 misconceptions, and then I'll go to the use cases, how can we use it? These smart contracts. Like I said, smart contracts vary by blockchain. And quite frankly, smart contracts on Bitcoin, although if there are some Bitcoin fanatics, I'm sorry about that, but Bitcoin really wasn't designed for smart contracts. Bitcoin was designed for transfer of value in a very robust and a good manner, and it's the mother of all blockchains, and we're still very grateful that it was ever invented because it opened up a lot of possibilities, but it's not invented for smart contracts. So we can deal with smart contracts in a very stringent way on a blockchain, but not Turing complete like in Ethereum. You can't program it as you like. You have to adhere to certain rules there. So then we automatically come to Ethereum, because smart contracts on Ethereum are Turing complete. You can program like you want then, but basically you do have to learn a new language. You do have to learn Solidity, which sounds scary, but if you know your JavaScript, you know Solidity within a few hours, because they look so much alike, it's very easy to learn Solidity. And you have tokens, you have cryptos, etc. So you can transfer value over this blockchain as well, through these smart contracts. And that's quite interesting for a lot of use cases, and I'll show you that in the coming few slides. And then we have, for example, Hyperledger. And Hyperledger differs from Ethereum due to the main fact that it doesn't have a cryptocurrency. So the transfer of value has to go through the traditional system and not through the blockchain in itself. So you need third parties again to transfer the value in the whole system. So if you want to really do a rehaul of the old processes, you want to have a blockchain like Ethereum, and I'm a big Ethereum fan, don't get me wrong, but maybe they will be replaced in a few years by another. That can always be the case. Yeah. To put it the other way around, every token that's being built right now in the world, so tokens, not cryptocurrencies, are based on smart contracts. It's just a smart contract that we deploy, the so-called ERC20 token contract. So if you go to coinmarketcap.com, you think that you see like 1,500 cryptocurrencies, but in real life it's only 750 cryptocurrencies, and the other 750 are tokens that are created on top of a blockchain, in most of the cases Ethereum, due to an ERC20 token contract. Yeah. Yeah, you can build, in the end, you could build tokens on Hyperledger if you want to, but it has some downsides to it, because Hyperledger is a permissioned blockchain, and thus it's much harder to put them out in the market to create a value on it, etc. But let's not go into the economics of it. Yeah? And finally, you also have new blockchains coming up, like Neo, like Cardano, like EOS, etc. But please bear in mind they're all early stage. I wouldn't do anything on those blockchains yet. Wait for a few years before they get a bit more mature. Start experimenting with them, but there's still a lot of flaws in there. For example, Neo, a few months ago, had a problem with their consensus model, which is like the basis of any blockchain to work. They couldn't perform any transactions for a certain period of time. And then we found out that there were only 7 consensus nodes in the world, and all owned by the same foundation, which is kind of tricky, because back centralization in this case. All right, let's up some potential effects on business models in the future. Yeah. Yeah.
In 2 of the blockchains you mentioned full smart contracts, and in 1 you mentioned just smart contracts. So what is the difference
The difference is that I forgot to put in full smart contracts on a hyperledger. Yeah? No, in basic, they're all Turing complete. So you can, the distinction that I wanted to make is these are Turing complete and the other ones aren't. Yeah? All right. So the potential effect on business models, and now it becomes interesting. What can it change? What can it really change? And not only blockchain, but smart contracts in itself. And do bear in mind that both the examples that I will give you right now, we have already built. They are already working, but we have a lot of other hurdles, like the law that needs to be changed, etc., before we can fully implement them. But the first example is how we deal with VAT. And everybody who is ZZP'er or has as me knows how annoying VAT payments can be, especially payments and refunds, etc. It's a lot of work, a lot of hassle, a lot of administration for small and medium enterprises. So what can we do? Right now, we can really change the way we work. We can really change from accrual accounting, basically keep track of all the payments that I did and all the payments that I received for a certain period of time and then add it up and sum it up, etc., and then communicate with the tax authority to do it on transaction basis, transaction by transaction. Because what we can do now is that if I send a bill or an invoice to my supplier, to my customer will pay my bill on my accounts receivable. And my accounts receivable, in this case, is not a standard account that I have by the bank, but it's a smart contract account. And as soon as it comes in, my smart contract scans the incoming payment, what kind of payment is it, and says, hey, the non-VAT part can go to my account payable, and a VAT part immediately goes to the tax authority. And both my accounts payable and my tax authority account are smart contracts as well. So, in the incoming payment from my customer, I already paid my taxes with regards to VAT. So no more hassle that I'm behind with payments, etc. It's automatically done at that point. But if I want to pay my supplier, I send a message to the smart contract saying, hey, I will have to pay, say, 100 to my supplier. So when I send this message to my smart contract sends the 100 immediately to my supplier in this case, but also calculates what's the VAT part of it. What is the VAT part of this 100? Because in outgoing payments, I have to pay VAT as well. And then it sends that amount of VAT as a message to my smart contract account at the tax authority, and my smart contract account at the tax authority immediately refunds it to my accounts payable. Meaning that I did my refund, or I got my refund, in my outgoing transactions, because this all happens in the same transaction. So no delay there, it's the same transaction. And that means that I don't have to do tax reporting as well, because everything at the tax authority over there is the result of my payments and my refunds, including the whole history of the transactions. They already have all the transaction information there, so I don't need to do any reporting at that point. And this sounds maybe easy or trivial, but this really changes our whole accounting system that we have known for 800-900 years now. So that's quite a change. And we weren't able to do this until 2 years ago, having that said, without the use of a trusted third party. So we don't need banks for this to do this anymore. We can build this on top of Ethereum ourselves. And to be quite frankly, the combination of these 3 smart contracts in the simplest form with just one rate of VAT, that's how I built it just to test it, and it was 21%. But it took me, in total, all the smart contracts combined, 130 line of code. That was it. And that can really get rid of KPMG and Deloitte and all those companies if we want to. Yeah?
Did you get some cooperation from the Dutch tax authority to make this happen?
Well, actually, one of the people of the Dutch tax authority is with me in the ISO World Standardization Group, and also the KPMGs and the EYs of this world are really looking into this, because they already say that the disruption won't come from the other big 4, it will come from this kind of initiatives. But right now the Dutch tax authority, that depends on which country. In the Middle East, they're highly interested, because the Middle East never had VAT until next year. For the first time ever, they're going to do VAT, and they're highly interesting to do it like this. The Dutch tax authority, they are interested, but I don't know if you know the state of the Dutch tax authority at that moment. They kind of have other problems. They did a reorganization and gave such high bonuses that everybody accepted, and they just thought that 20% would accept it. So it's yeah. So it's yeah. Yeah. Well, I'll come down to that one. So the percentage in itself is not a problem. Yep.
That's a related question. How do you handle the law changes?
Yeah.
How do you actually keep the whole? The question is, eventually, to get this to be flexible enough to lose the distribution of the blockchain and centralize everything again and go back where we started?
Not agreeing on that one. I'm in the end, blockchain will decentralize a lot of things, but we will have centralized parties that will keep track on certain things. So, for example, the VAT amount percentage to be updated, you don't want any personal person to do that, but you want one authority to do so. So we won't get rid of all the authorities in the end. We have to be realistic on that part. But I'll show you how to deal with this flexibility at the end of the presentation. Another example that I will show you is how we can build smart contracts for allowance for parents to kids. And I don't know how many parents are here in this room, but this is quite handy. Yeah, I'm a parent myself. And actually I showed this first in PowerPoint and later in a live demo to a trust company. And the people from the trust company said, okay, that was kind of our business model, so you killed us right now. But what we can do there is that if a parent wants to transfer value to his kid, but he doesn't want to do it directly, then nowadays we have to go to a bank or a trust agency, etc., to hold onto these funds. But we can also send these funds to a smart contract. And as soon as the funds are on the smart contract, the parent doesn't have a saying over the funds anymore because the code of the smart contract has the saying over the funds. And we can code it in such a way that as soon as the money is in, the child can control the funds. They can control a function that can actually trigger the funds. But now the fun part comes in for the parents. You can code it in such a way that you say, well, yeah, you can have access to the funds, but you can't spend it in shops. But you can spend it on tuition if you want to. Well, that's kind of, the fun is away for the kid at that point. But you can also build in additional rules. A very simple rule, and it's just a very simple counter, is, oh yeah, and by the way, you can only spend it when you're 18. Or if I'm dead, but then I need a notary to send a message to the smart contract that I'm dead. So it is that's the good thing about that. It's binary. It's 1 or 0. So sorry. But you can also build additional rules in, saying, well, until the kid is 18, I can change certain rules still as a parent. So I still have a bit of saying with regards to some rules, but not with the funds in itself. So in this case, I can say, well, this 18, my son is 17 now, let's see how he performs, I'll up it to 27. Maybe that's a better idea. If I was my parents, I would have done that. That's for sure. And this may sound far away, but first of all, I built it in a demo for the trust company ourselves, and a tailored version of this one is already live in the Netherlands by one of the municipalities. So there's one city in the north of the Netherlands, gemeente Zuidhoorn, who actually has this working, but not for a parent-child relationship, but for a so-called persoonsgebonden budget. So it's an extra budget for people who don't have too many incomes. And how they did it over there is that they will put some money into a smart contract, and they will allow the parents to spend it in a toy shop, but not in a liquor shop. These kind of things. So we then for sure know that it can go to a certain shop. Yes?
So you're saying you can still change some of the...
Yeah, I'll come down to that one later. Yeah? Okay. All right. So, and then technically speaking, the rule... Yeah, okay. Hold on. Yeah.
I have children, but I have to pay them Ethernet?
Well, no, in this case, it depends. What we can do here, right now, the easiest way is to do it in Ether, and then hope that the volatility will die out and will be stable. Yeah, so that's one thing. But what we also can do there is put in tokens. And a token where any company will say, okay, we accept this to the fact that this token is worth €1. So what we need to go towards is so-called stablecoins, where we can change these tokens in one-on-one for a fiat currency or whatever. We're not there yet. The crypto world is just too young to have that yet. There are some initiatives, and in this case, the municipality has tokens, and then the shops can give these tokens to the municipality, and they will get euros for the tokens in this case. So that's just an agreement. But it would be better if it would be a stable currency without the banking world around it, etc. Yeah? And CCV can still build the wallets. That's no problem. All right, so these are just 2 live examples. So let me get down to the last few slides. I'm way off my time already, but that's okay. I'm used to that. Jana knows me a bit longer. So, so how do we go towards building robust smart contracts? Because it is quite tricky. If we code it wrong, we can freeze money, and quite a lot of money. The Parity 2 incident in November last year, by sending a wrong message to a smart contract, we froze $160 million in assets, and we can't reach it anymore because we sent a wrong message to a smart contract. So we have to be quite careful about how we code them. And the first thing is that we have a huge knowledge gap at the moment. And that has to do due to the fact that anybody who wants to can build a smart contract, and that smart contract can hold the value and can hold the rules for the transfer of value without any knowledge of compliance, risk, etc. As long as you can code a bit, you can do it. So what we saw with the smart contract work group is that if we want to deal in a sustainable way with blockchain and especially smart contracts, you have to create people who have knowledge of blockchain in itself, software, and legal and risk in this case. And what do we mean with blockchain? Well, one blockchain isn't the same as the other one, so you have to have specific blockchain knowledge, but also, what is the effect on business models? It's really nice that we create business ideas and say we're going to do housing transfers without a third party anymore, but you do have to bear in mind, if you want to put this company live, that you have to change a law or two, so you have to go through parliament in order to make your business model work. It's kind of a tricky hurdle to take, I would say. Furthermore, we need new software knowledge. So new program languages are coming in, like Solidity, like Viper, like etc. There are many more new programming languages that come in. But also, very important, we need to create more people who can make translation front to back and vice versa. Meaning, from formal language, or how Nick Szabo would say it, from wet code to dry code. Like what we think in our head will go on, will a computer do it like that as well? And back. So are these translations correct? Because in the end, an end user will fill in something on a website and hit OK, and then hopes for the best that it will execute in a way in the background that they think it will execute. And oh yeah, if it goes wrong, there's no trusted third party anymore, so you can't call anybody to redo it at that point. So the risk is completely different. And that's the third point, actually. New legal areas, but also we have to deal with risk and governance. We have to deal with sustainable smart contracts that are really tamper-proof in this case. And building up knowledge in the individual pillars isn't a problem in itself. Where we see the biggest lack at the moment is the cross-functional knowledge. The cross-functional knowledge meaning coders who can understand a bit of governance, risk, and compliance. And not, we'll test something in a live environment, and if it doesn't work, we'll put it down and put up a new one, because that's kind of impossible in a blockchain. If you put it out in a live environment, it's out there in a live environment. And you can't pull it back anymore. Well, you can self-destruct a smart contract, but let's keep it for now. But also the other way around, especially with regards to this translation, it's nice that we create software engineers who can actually think like a lawyer, but I'm pretty sure that not all the software engineers in the world want to sign off on these smart contracts in the end. So we still need lawyers to sign off on it, but I can tell you, I have multiple of the top law firms in the Netherlands as my client, and a few of them I try to teach coding. That's quite interesting, I can say. So they're not the best coders in the world, but they will need to understand what is a function, what is a variable, what's an object. All these kind of basic stuff for us is completely new for them. So we have to learn from each other. We have to be able to start talking to each other. Well, that is a very important hurdle. Well, what are some important elements with regards to a good smart contract? Well, first of all, you have to have really clear terms on execution of the smart contract and the payment. Where does the oracle come from? Who's allowed to do it? And also, if applicable, some legal considerations to it if you want to build a smart contract that is a legally binding smart contract, because remember, large part of smart contracts are just pieces of workflow that we deploy on a blockchain and doesn't have to do anything with a legally binding agreement. And furthermore, you should have considered things like compliance, risk and fraud, privacy in a decentralized world, which is a challenge in itself, dispute resolution and unestablished legality, all things, maybe except for risk and fraud, that the standard coder didn't think of before. Maybe they thought of the risks and the fraud side by thoroughly testing it, but most of the coders didn't test it against the compliance rules, etc. So these are all new things to consider. Furthermore, if we then want to deal with upgrades, that was the question that we had from multiple sides. Well, remember, the code is immutable, so the functions are immutable. But where does most of the flexibility in any piece of code come from? It's not in the rule itself, not in the if-then-else statement. It's in the variables that are in the if-then-else statements. And the variables is something you can update. But first of all, before you want to update something, make sure that only the right people are allowed to update certain functions. And you can actually protect this within smart contracts on the function level. So on the individual functions, you can say, you're allowed to update it, you're not to, etc. So you really have to think about it. But then you can create flexibility through variables. And an example of a variable is the number of 18 or 27 years. If I put it in as a variable, well, I can update that from 18 to 27. And then all of a sudden, it's quite a flexible contract. We can do a lot of stuff in there. It becomes even more interesting if we can put amendments to it. And then we're coming into a tricky part, because we really don't have that much experience with our company. We're experimenting it right now on this part, but we're experimenting with proxy functions. And proxy functions are basically open functions where we, in the end, once the contract is deployed, in the future can link to a new smart contract that can have additional functionality, yes or no. And on paper, that sounds easy. In practice, it's really, really hard to do. Yeah?
Then we have a list of functions that we iterate in the smart contract, and we can track if true or false is active.
Yeah. Yeah, they can call each other, etc. So functions can interact with each other, contracts can interact with each other. So if I deploy a smart contract here and I refer to a smart contract somewhere else, and that happens quite a lot, they can interact with each other as well. But there is some trickiness to it, because then you enter the world of re-entrancy. So we go out of one smart contract and back to another one as well. And that's the most used trick for any hack. So it's something you should really be careful with. And finally, like I said, don't rule out the possibility for human interference. Even in smart contracts, we can have flexibility. We can build in gray areas, where we can say, okay, we reach an agreement, and then still there's a third party who will say it's 40 and 60%, or 50 and 50, or 70 and 30. Don't rule it out yet. So you can build in gray areas. And in this way, you can create flexibility. This one is quite easy, that one is quite easy. Here we're just at the beginning of figuring out how that will work in the end. Yeah.
So how much is the semantics of the events or triggers that come from these oracles? How much is that on the layer? Say that the economy sends an event that we find there is a storm in the Netherlands.
Yeah.
And then a year later they figure out, like, yeah, we can do a bit more detail. Let's send events for every province.
Yeah, but
the old smart contracts are triggering, what is it, 15 times or something?
No, because you can build a smart contract. Once it's triggered, it won't be triggered again. So you can sell, I mentioned it quite quickly, but you can self-destruct a smart contract. So once it performed its action, you can call a self-destruct and makes the code inactive, basically. It makes the code null.
But you keep relying on the fact that this trigger has one exact meaning, right? Because the meaning you change, you have a problem.
Yeah, but that's nothing different in real life, because if we have a contract and we pay out with Storm and we agree to the fact that we go to the KNMI database, and in a year's time the KNMI database changes, then we will still have a dispute and say, hey, what happened there? So that the execution performed automatically or manually doesn't change the factoring.
Yeah, that's true, but impact will be significantly bigger if this transparently happens in real time as the figure changes.
Yeah.
You don't identify it.
And but then we come into the legal world. Then you have to build something into your smart contract stating once it's triggered and we accepted it, we can't come back to it. Period. That's the easiest solution to do so. Final 2 slides, I think, and then we're really there. So some best practices. It is an open source world out there, and a lot of mistakes have been made for you, so you don't have to do that. That's quite nice. So everything is open downloadable. MIT Labs did a lot of good stuff already, built very solid smart contracts, very tested through smart contracts where you are sure that there are no loopholes anymore. So please figure them out before you start making it yourself, because a lot of work has already been done out there. At the moment, the last estimation last week is that there are already worldwide 250,000 people coding in Solidity, which is extremely large number considering the number of D apps that we have live in the world. But that was an estimation by a research company. Furthermore, any smart contracts, and this is what I saw last Monday as well, we are very spoiled with calculation power, etc. So we program all our program piece of code quite long. Keep it as simple and as stupid as possible. So make the code as brief as possible, as short as possible. Make functions very simple. Don't start making a smart contract of 500 lines if you can do it in 120 as well. For 2 reasons. 1, your surface of attack is much lower, so chances of you making a mistake is much lower in this case. And secondly, and this is maybe good news for people who coded in the old days. In the old days, you had to really take into account calculation power in your coding. Now, as we deploy it on a network which is freely usable, well, nothing is for free in this world, so also blockchain isn't for free. If you deploy a contract, you basically pay per line of code that you deploy. So the less code, the cheaper your contract. So it's as simple as that. And finally, as we are in a new world, it doesn't mean that traditional means of testing, etc., are gone. Traditional means of testing are still very, very good to do so. To put it even more in perspective, right now, due to the oddities still in Solidity, for your imagination, it's Solidity, which is the most used smart contract language in the world right now, is in version 0.4.24, so we're still not at 1.0. And it has a lot of oddities in it, that it reacts in a certain way that you don't expect. So do 100% code testing on that one. Well, finally, what are some smart contract enabling blockchains and what are some interesting developments? And then you can have lunch, okay? Well, there are a lot of smart blockchains out there that claim to have smart contract functionality now or in the future, and especially that last part people tend to forget when they read that a smart blockchain can do smart contracts. And at this moment, there are really 3 platforms that can handle smart contracts in a very good manner, and actually 2 if it comes down to. 1 is Ethereum. And people who come up with Quorum, etc. Quorum is just an Ethereum-based platform. And Hyperledger. I wouldn't trust Neo at the moment. Can be trusted within a few months, but not at the moment. Ethereum is permissionless. Hyperledger is permissioned. So you have 2 major blockchains where you can develop smart contract on. You have other smart contract enabling blockchains, but they're much more rigid. You have to work with templates, it isn't Turing complete, it's not so easy to use as the other 2. And finally, you have a few that have a very good promise that they will have smart contracts, but don't have smart contracts functionality yet. Best example, I would say Cardano. They just launched their first ever smart contract testnet a week and a half ago. And Cardano in itself, by the way, is worth $9 billion now, Jana, do you know that? Something like that. $9 billion just on the promise that they will have smart contract functionality. So what are some interesting developments that are going on? Because it's a fast-moving world at the moment. And there are 5, and the first one is something that Jana touched upon as well, things like zero knowledge proofs and zero knowledge range proofs. That means that in a permissionless, in an open blockchain, we can interchange information without revealing the content of the information. So we can deal with privacy, and it goes way too far to explain how it works, but there are some really great initiatives going on there. So that means that the number of use cases that we can use in a permissionless environment are rising at the moment. The second thing is, right now, if you want to trigger a smart contract, you have to pay for it. So the one sending in the transaction has to pay for triggering a smart contract. And in the next version of Ethereum, it is the idea that smart contracts themselves, if they hold a balance, can pay for you. And also that might sound trivial, but it means that anybody who opens an account on a wallet doesn't have to own any ethers in order to interact with a smart contract. So that opens like 50% of your use cases, where you can use it for later on. Thirdly, right now, we are quite stuck to Solidity, but there are many more languages and also traditional languages coming up where we can build smart contracts in. So that is developing rapidly as well. And fourthly, and that's quite interesting as well, is that we work towards drag and drop systems. So we can basically, where 20 years ago you had to really know your HTML to build a website, and now with WordPress you can build it as well. This is happening in the smart contract world as well, where we can drag and drop functionality into it, making it much more easier for people than just to plain code them. And finally, we're coming to more and more standardization. And it's quite funny that the only standardization so far is the ERC20 token contract, so we can create tokens and do ICOs and make a lot of money. That's the only standardization that we have, but we're getting more standardization in there. And there are more organizations work to standardization, so we can reuse code much more. And also to very simple questions, semantic questions, like an owner in a smart contract on Ethereum, is it the same thing as an owner in a smart contract on Hyperledger? Because these blockchains now don't talk to each other, because there's no interoperability yet, but maybe in 2 years there is. And then it would be quite handy if we would mean the same thing with owner in the different various blockchains. That was it. I refer to Smart Contract Report. That's the report on the upper right-hand corner for you guys. It's freely downloadable from the site of the Dutch Blockchain Coalition. Much more information in there. And in September, a new book comes out, The Legal Aspects of Blockchain. And I always find it quite funny that I wrote a lot of legal books being an engineer. But thank you very much, guys. I hope you liked it.